So anyone who works with fiber will tell you there are three things that you cannot live without when you have the responsibility of one, service activation, or two, troubleshooting why service is not working properly. There are three fundamental tools. There are other tools, but these are must-haves. The first is a fiber scope. The second is a meter that will allow you to measure one or multiple PON wavelengths. And last but not least, for troubleshooting, it would be an OTDR. So let me explain the fundamental reasons why you need each of these tools. And they can be a combo test kit. I break them down as three individual test functions, but they can be three independent test sets or one kit, if you will. So fiber scopes. Everyone has known that the number one cause for poor quality or outages in a network, in an optical network, has been the optical connector. Like most other technologies, the connectors are always the weak points of the network. I would venture to say that 70 to 80% of the trouble on optical networks is due to poor quality connections. A fiber scope is a tool that is designed to allow technicians to inspect the end face of the connectors to see if there's contamination or if there's permanent damage. Depending on what the scope reviews, the technician has two ways in which to address it. If it's strictly contamination, there are many types of cleaning supplies that are available out in the market for them to bring that connector end face quality back to factory condition. However, if the fiber scope indicates that the damage is due to improper care and handling of that connector, they may have to replace that connector. But again, unless you have a fiber scope, you can't determine what your options are. Second, in order for you to have good quality service, you have to have the correct signal levels. Now the standards, the ITU and the IEEE standards basically say, if you are testing power level, depending on if you're at the OLT or the customer's ONT side, you should have a certain power level depending on the wavelength that you're going to be testing. So in this case, what I'm doing is I'm going to go ahead and use one of the three potential power meters that are out there. Your broadband power meter, provided there's only a single channel transmitting at the time, you can use that. And if there's a calibrated wavelength available. Number two is PONT. The assumption for people who use PONT, which is also called a terminated power meter, is that as long as I can get the correct traffic power level coming from the service provider, I can use a PONT meter and the network should work. That is the general assumption of a PONT. So you're checking for either 1490 for 1G or 1577 for 10G traffic. But the best tool for testing signal level is the power meter that allows you to measure both downstream and upstream traffic. So what ends up happening is you're going to have multiple downstream signals coming from the service providers, and when it gets to the customer will either have a 1G or 10G service that they've subscribed to, and they will send up their signal. The pass-through meters are injected temporarily so that the technician is able to determine both the quality of the downstream traffic and if there's a problem with the upstream traffic coming from the customer's equipment.